This video, I'm going to explain you complete EPC or engineering procurement construction management scope of supply and model-driven project execution plan. Either you talk about construction industry project, or you talk about oil and gas industry project, petrochemical, textile, cement plant. So this complete video, this complete chart is going to clear your concepts. If you are in planning or you want to start your job career in planning, this complete video is going to help you different stages of your project, milestones, and what kind of documentation required. And the most important thing, which I always try to deliver to all the people out there who want to start their job career in planning control, or they want to upgrade their job career as per multinational companies to pass job interviews in Gulf region, they should focus, they should attend this video till end so that they can grab the idea, they can pass job interviews. So in this video, you can see right now, you can see very complex kind of things. Things are overlapped with each other on this y-axis. I can just simplify this video for you people. You can see there is x-axis and there is y-axis. Along y-axis, you can see there is office bound, there is site bound, there is schedule objectives, there are disciplines, there are generic milestones and progress derivatives. Obviously, when we are going to work on project, we need all these things to carry out. These are overlapping things. And on along x-axis, if I talk about these all things given along y-axis, they have given the details. Like if I talk about site bound resources, there is detail that at which milestone I need what kind of resources, right? I will be explaining each and everything once I'm going to start to explain this diagram. But right now I'm going to give you an idea how to view this complex kind of thing. I'm just trying to simplify it so that you can understand. Actually, this complete diagram is absorbing a one very 1000 page thick book worth of, right? So it's very simple thing. And now you have to understand things one by one. This is office boundary. So whenever your project is going to start, it is very obvious thing that it's not like that you are going to start from the site area. You have to document information, details, different kind of reports. So obviously people from the office area are going to start work, and then site people are going to mobilize on the site area. So obviously these two things are going to represent me that what kind of peak I require in which phase. Like if I talk about office bound, you can see that the graph is on peak, right? Touching peak, okay? And these are the engineering people. They are also working on the office areas. Then designers, after engineering, after reporting is done, I need designers, then I need procurement people, then I need people who are actually detailing about those procurements, and then I need construction people, which is actually as double as these previous curves, right? Because in this phase, I'm covering site, right? I need construction managers, I need site welder, all those people are going to make it give up maximum high, maximum peak, and then quality control is actually getting along with the execution phase. So these are the requirement of different kind of specialist along with, because this complete x-axis is showing me from very start, from feasibility analysis to the delivery of my project, right? So understand these two initial things. So as I mentioned earlier, that everything over here is overlap. I can't skip like I'm understanding this point and I should skip this one. No. Earlier on the initial stage, I just made this simplified to explain that these two you can see blocks are showing me requirement of different kind of resources as per the requirement. Now I can see that if engineering is on the peak, why engineering is on the peak in this area? Because this area is basic design, right? That is why this is on peak. I need more engineers, I need more people who can work on the initial stage of my project, right? The consultants, the people who are expert in something like what kind of thing, like preparing feasibility analysis. So what does mean by feasibility? Feasibility, actually, whenever your project is going to start, just either you talk about building, road, power plant, building construction, or your refinery, you need to make evaluation of your project with respect to your budget, economically it is feasible or not, and technically, right? If feasibility is in terms of yes, you are going to proceed with your project with a authorizing document like project charter. So after that, you are going to conduct invitation to bid, right? You are going to invite different kind of contractors out there in the market to compete in that bidding, so that one of those contractors or service companies are going to win that project. So see, everything is overlapped. Within this, I need more engineers. But why? Because basic engineering is going on. I need designers. I need the people who are expert in this concept, capacity materials, right? Initial estimate, cost estimates, right? Extended phase, key documents. Then I need people who can make MTO or material takeoff from that basic engineering designs. They can make initial level good calculation sheets and all that. So then I can make you understand. Along with that, you can see I am explaining this phase, but along with that, you can see that what after feasibility, I'm supposed to conduct this model. This model, you can see that this is 3D type model or prototype, which is explaining to all the stakeholders about the available conditions we want to incorporate into that project. If any conflict is there, all the stakeholders can talk about it and can make a proper decision through the project management strategies and all that. Okay, so right after this model is set up, right, this is done, we are supposed to prepare a baseline schedule. This is very basic level project schedule, which is actually guiding you in this phase that what are the major milestones and how we need to conduct those milestones as per our current strategy. But after this everything is happening within basic engineering phase. Baseline schedule is done. Right after baseline schedule, we are supposed to prepare detailed schedule. Okay. And there is after this, see, these multiple things are in parallel, right? So different kind of people we are, we require to conduct all these things. And then we have front end engineering design. This study will be done right after feasibility analysis, when we are actually covering this model setup, baseline schedule. Baseline schedule is actually giving you the details when feed is going to happen, when this is coming under detailed schedule, right? Detailed schedule is going to give you the information with respect to time, with respect to cost, that these milestones. You understand? Baseline schedule is covering these two items, right? Feasibility study analysis, feed, and something like that, right? Initial milestones. Whereas detailed schedule is going to deal with the other documentation, right? So everything is actually overlap. So within basic engineering design, we are requiring maximum people belongs to engineering discipline, right? In office area, right after basic engineering, what we require people who are more expert in designing. On the basis of these reports, they are going to design the things, right? So they are going to prepare detailed engineering kind of things, core design analysis, peripheral designs, final prices and contracts. Obviously, you need to set up the conditions, that on what conditions you require this project to successfully execute and deliver. So detailed engineering is actually to finalize all designs. Either it is about structures, mechanical, electrical, plumbing, foundations, with detailed specifications and drawings needed for construction. So within this, you can see that core design and analysis is also mentioned over there. In-depth analysis. This is actually focus on structural, electrical, mechanical, whatever I have mentioned earlier. So that is going to address that one. And the second, this peripheral design. So this actually complements core engineering, adding additional systems, facilities, as per the requirement of the project. Okay, so then detail checking, right? The people who are going to make more details about that project, and the people who are actually dealing with the contracts. So actually everything is overlapping and is actually coordinating with each other, right? So see, this detail schedule is up to here, and the feed is done. Once feed is done, then your fabrication is fabrication details under detail engineering, right? Because here you need to understand under detail engineering, you have to carry out all these processes. And under this process, you need to understand your designers are in more demand and engineering is going down. So see, now after detail engineering, you can see that procurement is starting. What is procurement? Once your design is done, you need to take off material from that design, compile BOQs, BOM, right? What kind of material you require, what kind, total tasking, converting your design into the task sheets, that what you need to conduct, BOQs, bill of quantity. So this procurement is going to start from here. So see, your designers are going down. Now your procurement people, specialists, their task is going up and up and up, something like that, right? And along with that, obviously, for fabrication details, simple. See, it's this work will be started. This procurement simple over here. So right? Plant piping deliverables actually refers to specific documentation, drawings, calculations, and reports prepared during various phases of the piping design, engineering, procurement, and construction stages in a project. These deliverables actually serves as a milestones and reference points, ensuring that the piping system is designed, fabricated, installed, and tested per project requirement and in industry standards. So I'm going to mention over here different kind of documentations which are part of this plant piping deliverables, like piping and instrumentation diagrams. Okay. So these diagrams are also the part of this plant piping deliverables. This is actually detailed representation of the piping instrumentation, control devices, and interconnections within the plant. And then piping layout and general arrangement drawings, GAD, are also part of this deliverable. These drawings actually illustrate the physical layout of the piping systems, equipments, and other structural elements within the plant. They ensure that the piping is routed efficiently, safely, and within design areas. And then isometric drawings actually provides a 3D view of individual piping sections, detailing about the piping dimensions, orientations, and connection points, obviously having a vital important role in the fabrication and installation for the people who are going to fabricate them. So then there is a pipe stress analysis report. This actually stress analysis ensure that the piping system can handle internal pressure. Pressure is very important factor. Thermal expansion, obviously, and when because hydrocarbons or whatever the fluid is going through that piping and all that, that is going to be very important. And external forces. So then material takeoff. Your bill of material, I have already mentioned that quantity surveyors are going to deal with them, that how much quantification for the task to define from the designs, then welding and entity testing procedures, hydro testing, like and pneumatic test procedures. So also along with these documentation, you need to understand with that deliverable you are, because these things they are going to ask you in job interview. So line list and valve schedules, like you can see that line list categorize all pipelines in the plant by size, like 2-inch, 3-inch pipe, 5-inch, MR NACE, MR075, H2S oriented, something like that. Okay, material service and all that, right? Then flange and bolt schedule. Obviously, there are different kind of pipe schedules to 80, 20, X something. As built drawings is also part of this deliverable. Quality control, quality assurance. So this actually this one plant piping deliverable is carrying these all documentation. After that, once this one done, design is done, yellow off is actually making sure before starting the next phase. Parallel, we have to understand after feed we are supposed to start fabrication details, and plant piping deliverables are actually also conducted once fabrication details, because obviously information will taken from here and will be part of this deliverable, right? So fabrication details deals with the drawings and specs used to create customized components. And there is then QCP schedule. Okay. And this QCP schedule is actually dealing with your project timeline for quality assurance, okay, activities to ensure that each component meets industry standards and the things which are mentioned as per project requirement. So over here we have yellow off design and a quality check. Actually, this yellow off is actually a quality check marking completion of certain phases. Our component verifying, readiness before the next phase. And after that, actually, you are going to mobilize to the next phase. Like after fabrication details are done, you are going to make skid vendor mobilization. Like you are, as per procurement procedure, you have asked third party to prepare that skid or whatever. So skid, this stage refers to assembling and preparing prefabrication units, skids for transport and installation. Whoever the third party, actually procurement is the process to arrange all the resources which are not the part of organization. So you are going to conduct contracts, you are going to strategize how to acquire all those resources, either those are manpower, material, or machinery resources. So through procurement proper procedures, contracts, you are going to acquire all those skids. Skid is also kind of material resource. So after this, skid is going to be compiled, manufactured through the supplier or vendors, and then they are going to provide you on site area, right? Then above, piping and test packs and punches. So what does mean by piping, test packs and punches? Because these are parallel things are going on. So now you can see that I just forget to mention over it, detailing people are going to here, because here detailing was going on. Here procurement, because procurement, after right procurement, you need detailing, right? After only detailing task, you can assume that how much steel I need, how much 2-inch piping I need, right? So detailing oriented experts are in demand. And right after, I need that manufacturing of skids, I need more people on site area. I need people on office area, but now site based people are more in the requirement. As long as my site area work is on the peak, my quality people who are going to conduct different kind of tests to document reports, to verify deliverables, they are also in demand, but their frequency is like that, right? At the end, they are in much demand. So this, you can see how this curve is going on, right? So along with this, you can see that piping, test packs and punches. This is also same like plant piping deliverable. This is a deliverable. I will explain you that how this, what kind of data this deliverable is carrying. A piping test pack is a comprehensive set of documents that outlines the inspection, testing, and quality control requirements of a particular section of the piping system. Actually, it is used to verify that the installed piping conforms to the project specification, standards, and codes before commissioning. There can be different kind of test like MPI, UV, visually, right? Something you are going to test. So this actually ensures the quality, the incident should to avoid from the incidents and any mishappening. And within this, you can have different kind of contents like piping isometric drawings, hydro testing, pneumatic test procedures. See, whatever I have explained earlier, plant piping deliverables. So there is again a repetition of the documentation, but here you can see more of the process, how to conduct the process. So piping isometric drawings for reference, then static testing, how to conduct the procedure checklist for welds, flange connections, valves, material certificates, test results, inspection reports. So such kind of components are going to be part of piping, test packs and punches. And more of punches means a specific document which is actually going to cover deficiencies or the things which are not yet provided or installed, which is deficiencies. You can refer it, and in future you are going to incorporate all those things. So that is actually piping. So see, once this construction is done, you can see that construction phase is started, and how it is, you should keep an eye over here that how basic engineering is going to start, how detail engineering is going to start, and how procurement is going to start. Everything is overlap, and then construction is going to start. So see, in the start, construction is very less working start. With the passage of time, you can see that more construction work is on peak, and procurement is also on the way, right? Everything is overlapped. So like this way, you can see that as built mean that whatever has been built is going to be documented so that in future it can help to the operation, maintenance, or for the sake of the contract purposes you need to. So client documentation, obviously client is going to close the project. They are going to produce final documentation. They are going to produce the things as per the project requirement. So see, according to that, here you can see that which kind of expert need to be released, which need to be hired, and along with that, there are respective curves. And within schedule objective, you have baseline schedule. I have explained about it, what kind of things under baseline schedule and what kind of stages. And here we can see that there are different kind of milestones at the end. After understanding all these things, of course, you need to write down each and everything along with this video. You need to pause it, write down your milestones. This is the complete case study you can implement on any project, right? To make your concept in more clarity, right? But in our project as a planning engineer, you are supposed to provide the progress. So here is progress derivatives, like when your feasibility analysis is done, your 1%, when your 1% is going to be done, like your decision to tender, then 5% kickoff meeting, 10% your conceptual design closeout, there 20%. So there, as a planning engineer, when you are going to sit with your team, it's not like that you are going to make you are going to define that, okay, how many from this stage. I will be explaining in more detail this, because this is very important as long as it concerns with from project planning control. Okay, so what you are going to define over here, actually, just make sure about so now the last topic, which is actually going to cover different kind of milestones, which is also part of from start to the end level. And parallel to those milestones identification, we need to cover that how to calculate progress, or what are the divisions of our progress with respect to these milestones. So the first thing is feasibility, right? Feasibility analysis or completion over here, and kickoff meeting. Once it's done, we are supposed to give our project that it is going to complete 1%, this is 5%, 10%, 20%, 30, 40, 50, 55, 60. Obviously we are going to cover one, like ITB study, basic engineering, detail engineering, procurement. Within that procurement, there are different kind of things that like detail overview is going to cover, like then 40%. These are cumulative progress. Within that, this phase, I'm going to give you an example how to calculate, how to develop your approach as a planning engineer. This is 30%, this is 40%. So time interval or the specific phase progress is actually 10%. Now, as a planning engineer, you need to understand that what kind of tasks are being carried out. You are going to carry out here fabrication details, right? So fabrication details will be up to here, like, right? Something like that. So then, you can see that there is procurement as well. We are going to understand from the perspective of procurement. Obviously, that procurement is going to present that fabrication details, what kind of quantities or materials we require, right? So this 10% will be divided into the activities which will help to understand the process. Let's say long lead items, we need to make RFQ, okay, request for quotation, or RFI or RFP, request for proposal, depending on your project. Okay, then you need to make in float inquiry, right? Receive bids. Your suppliers are going to submit you bids with their specs and cost. Then you are going to TBE, technical bid evaluation, then approval. So this is actually then approval, then purchase order issue. One of the suppliers, purchase order issue. Sorry for this kind of things. And this is part of ordering, then manufacturing, then delivery. Simple. So this 10% would be equally divided into the progress calculation, like maybe ordering will be 2%, and 7% is manufacturing, and 1% in delivery. That is how planning engineer need to understand these milestones. So I hope this complete document is a philosophy explaining planning engineering philosophy, along with the quality, the development of schedule, the development of your team, as long as it concerns with your site-based and office-based people, then different kind of documentation, different kind of milestones, and what kind of things you need to carry out, as long as it concerns from the feasibility to bidding to basic to detail to feed, whatever you require, everything is there. And then the construction. Within construction, obviously you need to see that what kind of detail engineering. As per this detail engineering, you need to carry out construction, but keep one thing in your mind, that your procurement and your construction should be aligned, should be pre-planned, so that your construction date should not be disturbed. So that is the vision of a project planning engineer, to complete your project on a time, to deliver your project, to start up your plant or refinery, petrochemical, on time, right? That is only possible if all these procedures are conducted through a proper planning and scheduling, through a proper resource deployment with realistic productivity, with the proper strategy. So I hope you guys enjoyed this video. This was really a professional document, and if you want to take oil and gas or plant shutdown or EPC full training with Primavera P6, with more detailed process task, from designing phase to procurement to construction to long lead items to installation to commissioning, with different sample projects. You can take my services, paid services as well. I can consult you, I can teach you, I can train you, I can offer my coachings. So that would be honor for me to serve you people. So that's all. I hope you enjoyed this video, and please write in comment area that how did it help you people to develop your project planning and control vision and concepts. Thank you very much.